We don't know what dark matter is. Dark matter is dark because it doesn't interact electromagnetically with anything else. So how do we know that it's there? I mean, if we can't see it with telescopes, how do we know it's there? Well, we know it's there because while it doesn't interact, or very weakly interacts with electromagnetic radiation, it interacts gravitationally. So it has a mass, and any mass has gravity. And so we know that dark matter is there because we can detect its presence through how it's affecting other objects through gravity. So it's there, we can see it gravitationally, but we can't see it electromagnetically. So at the moment, because of that, we don't yet know what it is. There are a number of hypotheses for what it is. Subatomic particles, the so-called weakly interacting massive particle, or WIMP, is a key possibility at the moment. We would expect to find these dark matter particles in our particle accelerators on Earth. It's a very difficult observation to make because they're very weakly interacting apart from gravity, and yet we have not yet discovered them in the particle accelerators. So it's looking like the WIMP might not be the dark matter particle, and then that opens the question for what is it, and we still don't know. So very, very important. It's very important because it's a gravitating mass. It's even more important because some 95% of the mass of the universe, the material that's gravitating and is out there, is in this state, is something that's completely unknown. And that's a bit disturbing for an astronomer, but I have no doubt that we will determine what it is eventually. If it's a subatomic particle, we would need particle accelerators, such as the Large Hadron Collider and others. But if it's very weakly interacting, we need those detectors to be better than they are now. And so if we're not detecting it now, it's either because it doesn't exist or we don't have the capability to detect it. So we must wait for next generation of particle accelerator detectors. Now, there are particle accelerators in the universe, jets of charged particles coming from near black holes and whatnot, and those cosmic laboratories can produce higher energies than we can ever hope for on Earth. And so maybe from those sorts of accelerators, if we observe the jets from the centers of galaxies, for example, we might be able to detect dark matter candidates. So it's just more observations of these natural laboratories and then the laboratories on Earth. And we continue theoretically trying to determine if there are other candidates as well.